This is section 5.4, and we're going to talk about logarithmic functions. Last section was on exponentials, and now we're hitting the logs. And what we need to know is that a logarithm is just an exponent. And it's the exponent such that 10 raised to that power. So if you say log of 1,000, that's 10 raised to what power gives you 1,000, and that'd be 3. So a logarithm, in this case, the log would be 3. So just think about that. It's not anything big deal. It's just an exponent, and the base of a common log is 10. We don't write it. Usually you just see it like this. But if there's no log number here, if there's no base, it is a 10. It's understood to be 10. All right, now a little bit of, so we have log x and we have ln x, which is a natural log. This base is 10. The base of an ln is e. Now, if we look at our calculator over here, so log, right here, you can see 10 to the x is what you get when you do second and the log, and you get e to the x when you do second ln. So they're on your calculator, and that will be good and helpful. Let's go forward. So if we were asked to evaluate log of 100, you want to think about it. There's an understood 10 here, and 10 to what power gives me 100? It's not 10 times 10, it's 10 squared. So 2 is what we get there. And then 1 over 1,000 is the same as 1 over 10 to what power? Okay, so 10 to the third gives us 1,000. So since it's on the bottom of the fraction, that log would be -3. We also need to remember these things. The square root, or the y root of a to the x, if you change it to fractional, the number here, the numerator, becomes the numerator. And the index here, y, becomes the denominator. So the cube root of x to the 4th is x to the 4/3. The 5th root of the y to the cubed is y to the 3/5. And for square root of x, we don't have any numbers written usually. They're understood to be a 2 here and a 1 here, and that's x to the 1/2. Write this down. Remember this. You cannot take the log of a negative number. So that will affect domain and a couple of things that we'll see, so keep that in mind. Now, let's talk about some vocabulary here. If you see log and an a and a y and an x, whatever those numbers happen to be, or let's put it in numbers, log 4 of 64 equals 3. This number is the base, this number is the exponent, and this is the argument. So there's two forms to remember. Log base of argument equals exponent, and then base 2 exponent equals argument. Base 2 exponent equals the argument. So this is log form, this is exponential form. You will have to be able to go both ways. All right? And then if we don't have a base of 10, sometimes we need to do the change of base formula. It's the log of the argument over the log of the base. So here it would be log of 64 over log 4. Now, if you do not have a calculator that has this, then you will have to use this formula. But I want to show you on your calculator. Let's get out of the finance. All right. So if you go to math and just go your up arrow, that's quicker. See this choice, log base? So you might have that on your calculator, math and log base. We hit enter, and now you can just fill in log base 4 of 64. enter, and you get the answer right away. So math and log base, that could be helpful. The domain of a log, remember we said that you couldn't take the log of a negative number. So the argument must be positive. So you take that argument, whatever's in those parentheses, set it greater than 0 and solve, and you get your domain of the log. Okay, let's see. Not going to do that. Okay, so if we had any log equations, we want to remember to switch to exponential. So it might just say log x equals 2.5. Well, there's an understood 10. So you put your 10 here, and remember to switch. You go 10 to this power equals the argument. So 10 to the 2.5 equals x. You can do that on your calculator, and you get 316.23. If we're solving an exponential equation, and we're getting this a little early, but there may be some here, but the next section or two will be more of that. But if we have e to the x equals 5, take the natural log of both sides. So ln of e to the x equals ln 5. ln 5 is just a number. But there's a rule, ln of e to the x equals x. Or you can think of it, ln of e to anything is the anything. So since I have this, the ln and the e are gone, and I just have x. So x is ln 5. This is exact, but you could do ln 5 on your calculator. Let's put this up and just hit ln 5 and enter, and we get that number, and I believe, yeah, 1.609 is what we had. So exact has ln in it, or you can do it on the calculator and get an approximate. So intro to logs, let's go see about the problems. All right, here we go. Number 1, evaluate by hand if possible. Log of 1 over 1,000, and we did that one in our notes. Remember, the 1,000 is 10 to the third. Since it's on the bottom, that'd be a -3. 10 to what power gives us that? Number 2, log of 1,000 is 3. 9 log 0.01. So log of 0.01 is going to be a -2 because that's 1 over 100. And then 9 times that would be -18. And then log of 1,000 plus that, plus log of 0.001, that would be 3 plus -3, and that would give us 0. Number 3, log of the square root of 100 million. Count the decimals. Count the decimals. I mean, not count the decimals, count the zeros. And we have 8 zeros. So that would be, but if we take the square root, we should get 4. Okay, so I've added a little bit of work here to help you understand that. So when we've got it under the radical, we've got the square root of, and we're going to change that. We've got six zeros and then 2, so that's 8. So 10 to the 8th, and that's the square root of that. And so that's 10 to the 4th, and so the logarithm is 4. If you take the square root of 10 to the 8th, you get 10 to the 4th, and so 4 is your answer. If you have the 9th root of 100, that's the 9th root of 10 squared, so that's 10 to the 2/9. Your logarithm then is your exponent, so it's 2/9. The cube root of 1 over 100, so you've got the cube root of 10 to the -2, So your exponent, if I wrote that out here, would be 10 to the negative 2/3. So there's that answer. Inside here, and we've got all these zeros in 1, that's 8 places, so 10 to the negative 8, and there's a 2 there. So that's 10 to the negative 4, and negative 4 would be our answer. All right. Number 4, find the domain of y equals log 8x plus 1 analytically. Now, if we take the argument here and set it greater than 0, subtract 1, divide by 8, so 8x is greater than negative 1/8. Then it says you may want to check your answer graphically. Let's look at the calculator. Let's go look at that. Let me see if I can get that over here and not be so... Okay. All right, so we're going to go to y equals, and we're going to clear that out, and we're going to put log 8x plus 1. And we're going to do a zoom 6. And we can see it starting right there. I'm going to do a zoom 4 just to go in a little bit. And I could zoom in a little bit more, but you can tell that it starts right up to the left of 0, so it makes sense. Negative 1/8 to infinity. So that just verifies that our domain starts about negative 1/8. Okay, find the domain of this one. Now this is, we're doing this, we could do it on the calculator, possibly. It's a little bit more trouble with a parabola. So choose the domain of the function. We've got to do that. So if we go ahead and factor that, we've got x minus 7 and x plus 4. All right, so we've got this factored, and we want to solve those two. So we have x equals 7 and x equals negative 4. You want to draw lines on another number line and put those in order. So here's negative 4, here's positive 7. And you're going to pick a test point. So anything below negative 4, I picked negative 5. A number between negative 4 and 7, I picked 0. A number greater than 7, I picked 8. You can pick any number that's in that interval. And then if I test negative 5 right here, negative 5 minus 7, that's still negative. Negative 5 plus 4, that's negative. If I test 0, I get negative and I get positive. If I test 8, I get positive and positive. Okay. So now the multiplication of these two signs, this is the easy way to do it. Negative times negative gives you positive. Negative times positive gives you negative. Plus plus, you get plus. Remember that we're talking about these two being multiplied together because this argument has to be positive. So it's a quick, easy way to say multiply the signs. And you're looking for where it's positive. And so you have two options. You have up from negative infinity up to negative 4, or you have 7 to infinity. So it is right here. And it was because that argument had to be positive. So number 6. People miss this all the time, and it's really the easiest thing in the world. So the log base 3 of 3 to the 4x is saying 3, the base, to what power gives me 3 to the 4x? Well, it's the 4x. So anytime you see that, that one should be pretty easy. ln of e to anything is the anything. So that's 8. What did we just say about this one? It's very much like here. Log base 3 of 3 squared is the 2. Log base 9 of 3 is saying 9 to what power gives me 3? Well, it's got to be a fractional power because we're going down. So it's 1/2. It's the square root of 9, and that is 1/2. ln of e to the 4th equals 4. Log base 6 of 1/36 6 to what power gives me 1 over 36? That'd be a -2. Log base 1/3 of 27. 1/3 to what power is going to give me 27? It's going to be a -3. Now you can do those on your calculator, especially if you have that log base app on there. But that's what you're thinking through. Number 13 is trying to get you to think about it without really the numbers. Change each equation to its equivalent log form. Remember that if it's a base of anything other than e, you use log. If it's e, you'll use ln. So that's the first thing to think about. So 8 to the 7z equals 7. We're going to choose the log option, so this one. And the exponent is always going to go here, so the 7z goes here. Log base 8 of 7. Okay, log base 8 of 7 equals 7z. They kind of got it written backwards. E to the z equals 9. Well, that's ln, and you don't have a base e, but the exponent is here. I mean, the exponent is here, the z, so it's ln of 9 equals z. B to the z equals g. Well, that's a log because we don't have an e as a base. The base is b, the exponent is z, g is left. 14, write as an exponential equation. Remember this. So base to the exponent equals x. 2 squared equals x, and that's all they want you to write there. 15. Solve this exponential equation. Now what we need to remember is if we can write something with the same bases, we can just get rid of the bases. So 1 million is 10 to the 6th. Now we've got 10 to the x equals 10 to the 6th, so x has to be equal to 6. E to the x equals 5. I think we talked about that in the notes. We're going to take the natural log of both sides. ln of e to the x equals ln 5. This becomes just the x equals ln 5. They want you to round to 4 places. So do that on the calculator. Hit the ln key, hit 5, enter, and you'll get this. All right, 17. Use the change of base formula to approximate the exact answer. All right, so we have 7 to the x equals 3. And one of the ways to do this, there's another that we'll learn in another section, but one is to use the change of base formula. But in order to do that, we're going to take, since 7 is what's being raised to x, we're going to take the log base of 7 to both sides. So we're going to say log base 7 of 7 to the x equals log base 7 of 3. Now remember, we just had a couple of questions where you had a log base 7 of 7 to the x always equals this. So this is all gone, and we have x equals log base 7 of 3. You can either use change of base formula like this, the log of 3 over the log of 7, or you can go get the log base and use the little icons and fill in your numbers. Your answer should be 0.56. All right, let's look at that last one. Graph y equals f of x and state its domain. So this is one where you have to use the tool, and you'll choose the logarithm tool, which is going like that. You'll click on the origin, and in the palette, you'll put that there's a horizontal shift. It shifts 1 to the right. If it's -1, it's going to the right. So you'll put in that horizontal shift to the right, and you should be able to get your graph. Hopefully, choose the right tool, click on the origin, that palette will come up, put in the horizontal shift. So I think that'll get you going on logs.